Mhm. Wow, who's someone? Oh, great. So this is assignment number 14, and this is problem number one. And we're just going to make sure. I know the TV, I was testing you guys, that, you know, making sure you're. Oh, we've got a glitch. Let's, there we go. Wow. Oh, right. Uh, so we have f of x. So based on what you learned yesterday, what is it about problem one that we like? I mean, I know for some of you, there's not much to like about math, but what's nice about one? There's a one in the front. So you'll appreciate that on problems one, five. I guess that's it. So when there's no number in front of x cubed or the leading coefficient, then when you do the rational root theorem, all you have to worry about are the factors of the number in the back. So you don't have to worry about the one in front because it's pointless, right? So we can just jump right in. What are the factors of 24? Positive, negative one starts my list after that. Positive, negative two, correct. You missed one. Yeah, and you don't want to miss any because then when you go to build your bridges, you'll actually have two missing factors. So be careful. After four, right. And now we've built a bridge. So since we have positive and negative six, they bridge to make 24. So now you can just reconnect all your bridges. Who goes with three? Eight. Who goes with two? Nice. So that's the nice thing about that bridge method is it'll save you some time on the back end of it. Just you cannot miss any on the front end or you're going to be in big trouble. All right. And so it's time to start the game. Let's see if Captain Psychic over here can do it again. So I'm going to start by making my template. So I'm going to start my synthetic template with I always make them purple. So 1, 4, -8, and -24. And remember, this is the part that you could do in some sort of permanent ink because it's not going anywhere, right? And now we begin the guessing game. What do you want to try over there, Kriskin? I mean, anyone's welcome. Three? Three's fine with me. I'm down. Like you could have said any number on this list. By the way, how many numbers are on the list? 16 is the correct answer. There are 8 factors, but each one has to be considered positive or negative. So there are 8 times 2, 16. So if we try what Kreskin over there said, then we get going. 3 times 1 is 3, 4 times 4 plus it doesn't work. He was pretty quick on that. And you can see we overshot it because we're going to wind up with a 39 here, which will not give us a cancel 0. So at least 3's off our list. It's worst case scenario, 1 down, 15 to go, but there's no way it'll take us 15 shots. Any other input? Sure, I'm down. -4, that makes an early 0. That makes another 0, multiple zeros. And you see that we overshot it again, right? We get a 32, which will not give us the coveted 0. So what we're going through today is a little bit more normal, just FYI. That luck streak we got yesterday, while it was really cool, it's honestly pretty uncommon. What else? Say again? 2 is fine. Let's try 2. And you kind of want to be organized. We're not doing a very good job. Like I should probably be crossing things off as I go. Like things we try, we should make like a list or find a way to just document somehow. Because we've done 3 and we've done -4. Okay, so let's make a little list off to the side because we don't want to waste time trying the same ones again. So this is a 1, that's a 2, that's a 6, that's a 12, that's a 4, and we missed it again. Okay, so 2's off the list as well. What else would you like to try? -2's fine with me. Let's give it a shot. Drop the 1. There's a -2. There's a 2. There's a -4. I think we might have ourselves a winner here. -8 and -4 are going to make -12. Multiply two negatives, and there it is. We have a winner. So that's the normal sort of vibe or feel with this process is it took us, what, 4 tries? And sometimes it'll take 6 or 8 or 10. I mean, who knows? But the good thing is that synthetic substitution is really fast. I mean, like it goes real quick. It's a simple, slick process, provided that you're not making little mistakes, then nothing to it. So we have one. Woohoo! And now the job is to find the other two. And the other two will always result from the quadratic that's here. And so those numbers are 1, 2, and -12. Is the resulting quadratic going to be factorable? If I do x squared plus 2x minus 12, can I factor that? I cannot. My best shot would have been like x plus 6, x minus 2, or x plus 4, x minus 3, and those both miss the mark. We don't hit that 2 in the middle, so it's okay. We're armed and dangerous with the quadratic formula. We're not scared, so we're going to hop right in. So A is 1, B is 2, C is -12, bless you. And here we go. What does x equal? -2 plus or minus a big long square root. And what goes inside that? 4. Mm-hmm. Right. So rather than put -4 blank blank, what I'm going to do is I'm going to put +4 and then put 1 and then just omit the negative on the 12. Since you know it's going to come out to be positive anyways, then you can just turn it into +12. Right. So if you see it coming, then just kind of cut corners a little bit. It's no harm there. And that's all divided by 2 times 1, which is 2. Do you think these answers are going to be rational, real? I guess I should say rational, irrational, or imaginary. Now, if you say rational, then what you're saying is that the square root's going to go away. So it'll be irrational, right? Not imaginary, but we have to say irrational because, and then that may be moving too fast for some of you, but what happens is inside the square root, we wind up with 4 plus 48, right? 4 times 1 is 4 times 12 is 48, and 4 plus 48 is 52. And we know that 52 is not on our list, our red list of square rootable numbers. So we are going to have an irrational pair of solutions here. And you've seen this guy before. I say this all the time that at this level of math, you see so many radicals that you start to familiarize yourself with them, literally memorizing them. But if you haven't yet, that's okay. How do you break down a root of 52? Correctamundo. So you break it into a root with a 4 and a root with a 13, resulting in 2 roots of 13. And then as we always do, we basically sub out the old one and, they tag you're it, and we put in the new and improved guy. And there is the simultaneous Dorito division that we can do here. It looks to me like all the numbers can be divided by 2. And so this one is going to remain negative, but 1. This one's going to become a pointless 1. And this 2 on the bottom is going to become a pointless 1. Right. Even if this -1 had been a positive 1, remember that he has to stay to hold that structurally in place. Any other ones can go away, but he cannot ever. So what's our final statement here? Right. And then all we simply have to do is put a comma and then not forget our success early on. Well, our success was -2, I believe. So then we just put comma x equals -2. This is your mission for today, is to do this 7 more times, and that is, or 9 more times. Use the rational root theorem to find a list of possible candidates. Test those candidates until you hit a winner, and then that winner will always take you down to the ground floor where you can either factor or use the quadratic formula. Got it? You understand your mission? All right. I will leave the recording paused because then if someone says, hey, can we go over this or this, then I can add it to this. All right, cool. Keep me posted. Let me know if you need help.